Hey everyone, and welcome back. Today we're gonna explore some great utility types of TypeScript and see how they are making our code better and our lives easier. By getting to know these types, you will be more proficient and your type system inside your project will be more modular and robust. So for those of you who are new to this channel, I'm Johnny, a full stack developer with multiple years of experience, and I love to share all my knowledge and experiences here. That's the reason why I've created this channel here, because we don't stop where most other tutorials or even courses stop. Coding can become complex and can intimidate many of us, but if you really want to level up as a developer, you shouldn't shy away from that. That's why we tackle these complexities here and turn you into a better developer. Make yourself comfortable and get ready. Let's start with partial and required. So they're pretty much linked together. That's the reason why I want to show them to you together right here. And let's first take a look at our interface, which describes a user with some different properties who are all required for now. And let's take a look first at partial. We can first define our new type right here, which is called partial user. And now we want to use the partial utility type that is also built in TypeScript. And then we just want to pass in our user interface. And let's take a look at our interface first before. You can see that all properties are required for now. And when we hover our partial user, you can see that they are all optional. So what this partial utility type basically does is, as we've seen in another video where we talked about advanced concepts and also about map types, where you can transform the properties, it just adds simply the question marks here and makes the type of it a union type with undefined, because as you might have guessed, when the property can be optional, it can also be potentially undefined. That's the reason why here this union type with undefined is required. And on the other hand, we got our next utility type, which is very closely linked to the partial. It's the opposite of it. It's called required. And let's imagine we make our age and let's say our email right here optional. And when we define now a new type right here called required user, and then we can use the required utility type and also just pass in the user interface. We can see right now that all properties like the age and the email property that were before optional are now required. So I think partial and required are very, very powerful tools to transform our properties and make it more robust, because as I've showed you in some other videos before, it's always not so very dynamic. So we can also do the following. If I comment it out first, of course, we could also define this by hand, type partial user, and then just copying it and do this by hand like this. And now also add the union type with undefined. And of course, this is also very valid and it works, but as our definitions or our requirements on our user interface are growing, so let's say we add another property right here called address, and another property like is logged in, and this is a boolean, or we just want to also store a string right here as the age. This also requires us that we have to update our partial user type right here by hand. And this is not very maintainable. So using the partial or the required utility type is very, very dynamic, of course, and makes your type or your code in general more robust. So whenever you want to transform your properties, think about first if this will change in the future or it has the potential. And when this is true, then I would highly suggest you to use the partial or the required utility type. So the next two types on our list are omit and pick. And they are really powerful if you want to clone a type, but don't want to use all those properties in that base type. To start things off, let's take a look at our interface right here. That describes again our user, that holds different properties about a specific user. And now we would like to define two new types that are basically cloning this user interface right here, but we don't want to have all properties. So let's first take a look at the first one, which is omit. Let's say we don't want to have the phone property, and that's the reason why I like to call it user without phone. And now we use the omit type, and it takes in two arguments. So the first one, of course, is our interface. And now we can define our properties we don't want to use. And this is, for our case, the phone. And when we now hover over it, you can see that the phone is omitted. And since this is a union type, we could also put in more, like the age, for example, and the email. And now we see that we only have the name right here. And for the other way around, we have the opposite of omit, which is pick. And there we define all the properties we would like to pick and not we don't want to have. So let's say user with email and phone, for example. Then we use our pick utility type. Also, again, it takes in two arguments, which is first our user interface, and then we define just email and phone. Oh, and I have a typo right here. That's better. And now when we hover over it, you see that we have picked our phone and email property. Maybe you're wondering right now when to choose omit and when to choose pick. Of course, this is a question of personal taste, but I'm always saying if you want to omit more properties than you would like to pick, then use pick. And if you want to pick more properties than you'd like to omit, then use omit. Sounds confusing, but let's see this in action. So first I will insert those two sentences right here that we have a reference. Let's take a look at them first again. If you want to omit more properties than you would like to pick, then use pick. And on the other hand, if you want to pick more properties than you'd like to omit, then use omit. Let's see this in action. So to make this crystal clear to you, let's define a certain requirement for our new type. Let's type it out here first. So we want to clone the user, but don't want to have the age, the email property, and the phone property. So, and of course you can use omit and you can use pick. This is totally valid and gets you to the goal. But there is a slight difference in the amount of code you have to write. And this is why I personally like to follow those two, let's say, sentences right here. So let's first define the way with omit. Let's call this user1 and use omit. And we just put in our user right here. And I think we can copy it right here from above. Great. So when we hover over user1, you see all our three properties aren't in there, and it only has the name property. And for the second user, we use pick. And this is, in this case, at least from my perspective, the right way. So we just have to pick the one we would like to have. And we can take a look at our interface, and this is of course just the name. And when we hover over it again, it's also the same as in user 1, except you have to write less code here. And that's the reason why this first evaluation is true. And on the other hand, we can adjust our requirement right here that we only want to have age, email, and phone. So let's first adjust it. But we only want to have age, email, and phone. And then of course, we have to adjust our omit and our pick right here. So, and first we have to think about, okay, if we want to have these 3 properties right here, we can simply say, okay, then only omit the name. So, and only omit the name. So here we go. And if you want to use the pick, we have to, of course, specify all properties we want to have. And this is those 3 properties right here. So I'm copying it from above, and we have to insert it right here. And now let's double check. So user 1 has the phone, age, and email property, and user 2, of course, as well. But in this case, of course, as you can see right here, when we are using pick, we have to write more code than just using the omit. And this is the reason why the second theory or the second preference right here is true, because we pick more properties than we actually want to omit. So then use omit. Generally speaking, I would highly suggest you to pick the one that allows you to write less code. It's just simple as that. Great. So the next utility type on our list is read-only. And I've already prepared this user interface right here, as we've seen in the other examples before. And as you might guess from the name, read-only makes your properties inside your interface or type read-only, so that you can't change them after the initialization. So what does that mean? First, let's create a complete new type where we want to make our user interface read-only. So we type out read-only user. Then, as always, we actually use the read-only utility type, pass in our user. And when we hover over it, you already see that the read-only keyword gets added to all properties. And now we can initialize some user object. Let's type this as the read-only user. And we, of course, we need a name. Then we need an age. Then we need an email. And lastly, we need a phone number. So let's type also 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we try to change the user, or to be specific, a property inside this user. Let's say we want to change the email to be test@example.com, and we immediately receive an error that states that the email can't be changed, or that we cannot assign a new value to this property because it's a read-only property. And this is the real power of the read-only utility type, that allows you to create a new type, which is in our case the read-only user type, and make this completely immutable. And as always, you can define this read-only type by hand, like the following. Let's comment it out first and type the read-only user. And of course, you can define a complete new type by hand and add your read-only keywords as well. But as you might know from the past or from other examples, this is very unmodular, because when here something changes inside the raw interface, then we have to go in by hand and change it here as well. So this isn't very modular and not a very robust approach. So the read-only utility type is a really powerful tool. Unfortunately, there isn't yet a built-in type in TypeScript that removes read-only properties, so that's quite the opposite of the read-only utility type right here. But as you have seen my video for the advanced concepts in TypeScript, there is a concept called mapped types, where you can build your own utility types. And that's an approach where we can potentially make the opposite of read-only. Let's take a look at this. So for that, let's remove all our code first. And let's make our interface user to contain only read-only properties. And our approach right here is we want to create a new utility type by our own that strips away these read-only keywords right here. Let's say we have only 3 read-only properties. So we type out our type called mutable that takes in a generic type. And then we can use the minus read-only modifier to instruct TypeScript when creating this mutable type that we want to erase all these read-only properties. So how can we do this? We type in first our property in key of t. And of course, we want to have the actual type of that property. So we doesn't change anything of the property and of its type. Only we want to strip away the read-only keyword. So and now we are able to define our new user object. So let's first type it out. Of course, it's of type mutable user. And it holds a name property, an age property, our email, and lastly, of course, our phone number. Let's type in some random phone number right here. All right, great. So let's first hover our mutable user type. And as you can see right here, all our read-only keywords are stripped away. And now we are able to actually update or mutate our user properties right here. And we can use it. So user.age, for example, we can use a new age without an error. And of course, for any other property as well, blah, 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 at example.com. This is also very valid. Let's take a look at exclude and extract. So they are pretty similar to omit and pick, but the key difference here is that they only work with union types. So let's see this in action right here. First, we want to insert our base type right here, which is pretty simple. It's a type union of 3 types. And first we want to have a new type, which is only a number that gets inherited its value from the primitive value type right here. So we can first use the exclude union type right here. And now we have to pass in 2 arguments. The first one is the actual type union we want to extract some or exclude something out of. And then we have to define all the types of the type union we don't want to copy. And in our case, if we only want to have the number, we have to define a union type out of a string and a boolean, which looks like this. So, and when we hover now over the only number type, we can see that it's only of type number. Of course, you can also pass only one type right here. Then it is still a union type consisting out of number and boolean. But in our case, we want to only have the number. So that's the reason why I'm typing out the string and Boolean union type right here. And now we are able to define a new variable, which is of type only number. And yeah, this is true because it's a valid number. If I change it to a string, it throws an error because, as you might have guessed, type string is not assignable to type number. So let's revert this here again to make this valid. And now we can take a look at the extract utility type. So in the extract utility type is pretty much the opposite of exclude. And for the second example, let's say we want to have a type of only string by using the extract utility type. And here we also have to pass in two arguments, which is first our union type and then the type of that type union we want to have, we want to extract. And this is in our case only the string. So we pass in the string. And when I hover now over it, you can see that only the string got extracted and assigned to that type right here. So we can define another example right here. Let's call this string. And it's of type only string. And here we can say hello, which is a valid string. And when we hover over it, it's also a string, and that's correct. So when I pass in a Boolean right here, this is of course also false because the Boolean is not, this is true by default because I have to put in a value right here and not the type. So here we go. And here you can see, of course, that type Boolean is not assignable to type string, which is of course correct. So first, let's make that valid again here by passing in a valid string. And to round this up, you can say that exclude is the same as omit, but for union types. And the extract utility type is the same as pick, but for union types. And of course, the two monomics I gave you inside the pick and omit section are also valid for these two utility types right here. So when we explore the world of utility types built into Typescript, we see that there are also utility types that work with functions. And two of those are return type and parameters. And let's see this in action, how we can use and leverage them. First, we want to take a look at our function right here, which is really basic, as you can see. It's just a sum that takes in two numbers and sums them up and returns it. But now we want to have a new type that is very dynamic based on the actual return type of that function right here. And that we can accomplish by using the return type. Let's define our new type first. Let's call this sum return type. And then we can use the return type, which is like this. And then we have to use the type of operator and the function we want to extract the return type of. And as we can see right here, when we hover over it, it's of type number, which is in this case correct. And like we saw in other examples, you could also define this by hand by just omitting the return type and only type it as a number right here. But then we also get into trouble when the return type of that function changes. We have to adjust it here by hand as well. And as always, we want to write modular and robust code that acts to changes. And when I revert this right here, and now I don't define the return type right here, and we want to return a string right here, then we can see that the sum return type also gets updated. And this wouldn't be the case if you define this by hand, of course. So let's revert this right here again. Let's return a number. like this, which is great. And now let's take a look at parameters. There we can define a new type, which is some parameters. And then we use the parameters utility type. And then we also use the type of operator again and pass in our function. And here comes the very cool part about it, because this returns a tuple, as we can see right here, which defines the order of the types right here. And if I change this right here from B to A, the tuple order also changes. So the order matters right here because it's a tuple, and it reflects the original order of the parameters right here. So whenever you want to access the types of a function parameters, then the parameters utility type is your friend. Welcome back. So another pretty useful utility type I want to show you is the non-nullable utility type. And as you might guess from the name, it helps you to extract all null and undefined types out of a type union. So when we take a look at the first basic example right here, we can see where we have a new type of a nullable string that is either a string, it can be null, or it can be undefined. But in our case, it's not very beneficial if we use a nullable string, so we want to have a non-nullable string. And that's the reason why we can use the non-nullable utility type right here. So let's define our new type. Let's call this non-nullable string. And then we can simply use the non-nullable utility type and just pass in our type union, nullable string. And when we hover over it now, you see that all the null and undefined types got removed. So we just have the string right here, and this is of course non-nullable now. If we define now some variables using that type right here, so we can first define our first string, which is a nullable string, for example. And this can be null, of course. Oh, I've jumped around right here, so here we go. This can be null, of course, because it's a valid member of the union type. But when we change it now to the non-nullable string type, then of course we receive an error because, ta-da, type null is not assignable to type string, which is very valid in our case. And when we now define a second string, which has also the non-nullable string type, and we use a valid string like hello, this is of course valid because the non-nullable string has the only type of string. Now it's time to take a look at the weighted. So it basically allows you to extract the type of a resolved promise. So as you might know, when you have a promise in TypeScript, you have to type it like this. So you have the promise type itself. And inside those brackets, you are defining the type that gets returned when the promise resolves. So this can either be, for example, void, if the promise doesn't return anything, or it can be any other type, like for example a number. And to get access to this number typed right here, we can use the awaited utility type. So let's define a new variable right here that's called just number. And then we use awaited. That takes in our promise number type. And when we hover now over the just number, you can see that we got access to the number. And when we change this up here again to string, for example, we can see that we got access to the string. So let's revert this here again to have the number. And as you've seen in this basic example right here, you can see how powerful the awaited type actually is when you're dealing with promises inside your code. But I want to give you a more realistic example right here. Well, first let's remove this here again. And then we define a new promise function actually. Let's call this fetch data, which is of course asynchronous. And this returns our promise. And when this promise is resolved, it returns a string array like this. And then we just return a simple array right here with data1, data2, and data3. And our goal right now is that we want to get access to this string array type right here to use this anywhere in our code. And it's a little bit tricky because we have to combine certain things right here. And as we've seen in another section, there is a built-in type called return type that gets us access to whatever this function returns. So let's first accomplish this. So further down, we define our new type called resolved data. And then we first use the return type. And then we can type in type of fetch data. And when we hover over our resolved data type, we see, of course, that we got access to the return type of our function. But as you can see, it is also enclosed with the promise type because it's an asynchronous function. And that's the step where we are using the awaited utility type. So we can basically copy this return type definition right here and call first awaited and then put this in. And then we can see when we hover over it that we got access to the crystal clear string array type right here. Welcome back everybody. And the next type we want to take a look at is record. And this is really powerful and really helps you if you want to construct objects with specific types of keys and values. So what do I mean by this? First, let's take a look at our types that are already defined for us. And as you can see right here, we have an interface which holds certain properties about the user info. And we have a type union that holds 3 different usernames right here. And our big goal right here is that we want to construct an object later that holds information about our users so that the usernames are linked together with the properties of each user, as you can see inside this interface right here. So every type of this type union right here is actually a key later inside this object, and each value of each key holds those 3 properties. So first let's consider the bad approach, and I copy and paste it right here. So this would be the result if we would type this out by our hand. So as you can see right here, every member of the type union above is an individual key. And each key has our properties from the user info interface right here as its value. And as I've told you many times before, we want to write modular and dynamic code, of course. And I'm pretty sure that you have already seen that this code isn't very modular, because when we are adding a new member of this unit type right here, let's call this Tommy, we have to go inside here and have to define our new key. And this is of course very bad. So like this, and then we have to put in those 3 members as well. And as you can see, this is pretty redundant and not very modular. And the same is true if you want to extend this interface right here. Let's say we want to have another like address, and maybe the age could also be a string. We have to go inside every member of this users type right here and adjust it here as well. But thankfully, there is a built-in utility type into TypeScript that helps us accomplishing this on a more modular and dynamic way. So let's remove it right now. This whole bunch of type definitions right here. Let's remove this name here again, the address of course, and the additional type right here inside our age. And now we are able to define our users type right here by using the record utility type. So let's first define users, and then we are using the record, and then we have to put in two arguments. The first arguments describe how the keys look like or what types the keys should have, and the second argument describes the value of those keys. So of course we want to have keys for each member of that union type. So let's put in the username right here. And then after that, we define this user info right here as the second argument. Now we hover our type of users right here. We can see that each member of our union type got its own key right here and holds the type of user info. And further down, we can now define our actual object that is of type users. And to not waste any time right here, I want to insert it. So as you can see right here. And this is of course valid because each key is valid. And of course, the user info is also satisfied right here. When I change now something like this here, you can see that we receive a TypeScript error because Mike with 3 E's is not defined inside our username type union above. So let's first revert this again. And to round this up, the record utility type helps you to define strict types inside your object. For example, this can be very helpful if you want to type out some form data and that holds certain specified keys and specified values. And then you can leverage the record utility type right here to be type safe on that way too. Thanks for watching. That was a fun ride through some great utility types of TypeScript. I hope you enjoyed the video as much as I did, and feel free to drop a comment and to subscribe to this channel. So see you next time and happy coding!